Algebra Review. So in this lesson, we're going to talk about all different components of algebra that we went over the past year. That's going to be arithmetic sequences, geometric sequences, logs, and my favorite, the binomial theorem. So let's start off. Arithmetic sequences is a sequence where you add and subtract to get the next one. Like something like 2, 4, 6, 8. Every single time we're adding 2, that's our common difference. That's an arithmetic sequence. When that happens, we're going to look at all the arithmetic sequence formulas, which you can find right here. These two. If we want a single term, we use the top one right here. If we're looking for sum of terms, there's actually two formulas here. It does not matter which one you use. I actually prefer this one because all you need is the first term and the common difference in the number of terms. If you're going to use a shortcut one, you need to have the last term, which is a process to find sometimes. But it all depends on what they give you. How do you find the common difference? Well, there's usually not a formula for this. All you do is subtract. You go 8 minus 6. Hey, it's 2. Common difference. You usually do that in your head, but whatever. If you want the nth term, if I'm trying to find what's the 16th term of this, we'll use this formula. In your formula sheet, that's the common difference. That's what that says. N is a term number, so I'm looking for the 16th term. I'm plugging N there. A lot of times you have to look for the term number. You're not going to have that. In this case, that would have been the 2. And this is the term you're finding. So like, that's what that is. Some of the first N terms, as I talked about before, there's two formulas. There's this one, there's this one. So like I said before, I use this one the most because the first term you generally have, the common difference you generally have, and the term number you generally have. This one you need to find the nth term. Sometimes you already have that because like that was probably the first question, but if you don't, then it's a little more work. But that's the deal with arithmetic sequences. They're going to tell you, hey, this is an arithmetic sequence. You're going to find a common term, so you can use this. You're going to find a certain term, so you can use this formula. Or you're going to find the sum of the sequence, you can use that formula. So let's do an example. An arithmetic sequence has u20 equals 62, s sum of the first 20 equals 670. Find the value of u1 and the value of d. We'll use this one first. I'm like, okay, un equals u1 plus n minus 1 times d. This tells me when I plug in 20, I get 62. When I plug in 20, I get 62. That's all I have. I have 62 equals u1 plus 19d, 20 minus 1. That's all I have there. Let's look at this formula. They tell me the sum of the first 20 terms is 670. I could use either formula here. In this case, I think this one would actually be the easiest one because I have 20 terms. I know some of the first, actually I don't. I know S20 is 62, so I actually have this right here. Actually, this one's actually the easiest this time. S20 equals n over 2 u1 plus un. I know this is 670. That's what they tell me, 670. N is 20, so this is 20. And I actually have un this time. Right here they tell me u20 is 62, this is 62. This is 670 equals 10 times u1 plus 62. That's just mathematics, divide by 10. 67 equals u1 plus 62. Subtract 62, u1 equals 5. I have u1, go back here, plug it in, do a little mathematics, subtract 5, and I get 57 equals 19d, divide by 19, and you get d equals 3. My common difference is 3, my first term is 5. Arithmetic sequences. All about adding and subtracting. So if we're talking about adding and subtracting, look at your formula sheet. It's going to be one of these formulas. If you're talking about a certain term, use that one. If you're talking about a sum of terms, use that one. Sometimes you use both. Let's talk about geometric sequences. Geometric sequences have a common ratio. This is where you multiply and divide each term. For example, if I give you like 10, and then 5, and then 5 halves, and then 5 fourths. In this case, you're dividing by 2 every single time. Your r would be 1/2. The easiest way to find your r is this u2 over u1. Second term over the first term. That's all that means. In this case, I'll put 5 over 10 and reduce it. I get 1/2. So this is not a formula in your formula sheet. As you can see by our formula sheet right here, there's no formulas for r, but you kind of want to add that in yourself. On the side, you put r equals u2 over u1. And then when you get your formula sheet on the test, you just write that in. And just like arithmetic sequences, it all depends on what they're asking for. If they want a certain term of a sequence, use this formula, how you find your term number. If you want the sum of the first n terms, use this formula. There's actually 2 in your formula sheet, doesn't matter which one you use. And if they say infinite, they have to say that, infinite geometric sequence, then you can use this formula. It's a lot simpler, but it only works when r is less than 1. Absolute value r is less than 1. So if r is like 2, you can't do it. Right here I could do it, it's 1/2. But r has to be a small number between -1 and 1. But it's the same idea. So let's do an example. Geometric sequence has u1, 2, and a common ratio of 3. What term number will be the first to exceed a million? What we're going to do is look at our formula sheet. It says term number, it didn't say anything about the sum. So I'm looking at this one. These are all sum things. So it's all about this one right here. I'll put that down. Equals u1 times r to the n minus 1. Again, in this case, it said you want it to exceed a million. Let's plug our things in. We have 2, common ratio of 3, n minus 1, and I want it to exceed a million. That's just math. What we do next is divide by 2. Gotta get this by itself. 500,000. The way we saw this, if there's a variable in the exponent, we gotta take natural log of both sides. That way you can bring the exponent down. N minus 1, 3 is greater than natural log of 1500. Oops, forgot the natural log here. I'm going to divide by natural log of 3. I'm going to get n minus 1 is greater than natural log of 500,000 over natural log of 3. By now, I probably should put my calculator. Here's my fancy calculator. Turn it on. There's step 1, natural log of 500,000. Close the parenthesis, very important. Divided by natural log of 3. Very important, close the parenthesis. So many mistakes when people don't close that parenthesis. You get about 11.94, 36 for IB, 11.9. N minus 1 is greater than 9.9. Add 1 to both sides. N is greater than 12.9. Now again, you gotta be greater than 12.9, so that means n is gonna be 13 is gonna be the first term to exceed it. Geometric sequence, arithmetic sequence, we go by numbers. So it can't be a decimal. 13 is the first term to exceed 1,000. It's all about figuring out what they're asking. We want a term number, use a term number. If they ask you about the sum, use the sum formulas. Just plug it in, get to work. Next up, let's talk about sigma notation. Sigma notation is just a notation you have to be familiar with. But the idea here is you should know what this means. If I give you this, you should know what that means. And sigma here, if you see that symbol, it just means add. That's it. It just means add them up, find the sum. So all we do is start here at 4, plug it in. You get 4 squared minus 20. 16 minus 20 is negative 4. Then you did 4, now you count up, you go to 5. 5 squared minus 20. 25 minus 20 is 5. And then we go to 6. We're going to keep on doing this until we get to 7. That's where we stop. 6 squared minus 20, 36 minus 20 is 16. And then 7 on the last one, minus 20. 49 minus 20 is 29. You add all this up, you get negative 4, because that's the sigma part where you add them all up. I get 1, 30, 46. And that's the idea. That's a sigma notation. That's a very basic sigma notation. You just go, okay, start there, end there, plug it in, and then the E just means add them up. That's a basic one. What's a more advanced one? Well, the one like this one. You have 20 to 16. You could do it the old-fashioned way. Just go 3 times 2 to the 6 plus 3 times 2 to the 7th plus 3 times 2 to the 8th, all the way till you get to 3 times 2 to the 16th. So there's a shortcut way of doing this, which is, let's see if this is an arithmetic or geometric sequence. And if you look at it here, what's actually happens is you're doubling every single time. 192 times 2 is 384. I know, obvious. 384 times 2 is 768. This is doubling every single time. So you're multiplying by 2. Every single time. This is a geometric sequence because we're multiplying. And this E means sum. When we look at our formula sheet, we're looking at geometric sequence, looking for the sum. It's between one of these two, but we're not doing an infinite sum, but it's this one. So let's copy down the formula. Sn equals u1 times 1 minus r to the n all over 1 minus r. So the next thing is, how many things are we actually adding here? We're going from 20 to 16. A lot of people go, oh, it's 14, 20 minus 16, but what happens there, you're not counting the thing. Think about it logically. You're going 6, 7, 8, 9, 10. I've done that, 10, there we go. 11, 12, 13, 14, 15, 16, 17, 18, 19, 20. It's actually 15 terms we're doing. 20 minus 16 is 14, but what happens is that you're not counting the 20 or the 6, one of the two. It's always kind of one more. If you're not sure, just do what I did, 15. There's actually 15 terms. S15. The first term was 192. Then 1 minus my common difference is r, 2 to the 15. All over 1 minus 2. Next, let's talk about logs. So the key thing about logs is you should know how to do a basic log. Straight out like here, the expression log 2 to the 1/8. They might ask you what that is, and I expect you to know it. And it's actually not that hard. The key thing is this. It's how you read it. This says 2 to what power is 1/8. That's all log is. I'm going to start with the easier one first. Let's say I gave you log 5 to the 125. You're thinking, okay, 5 to what power is 125? That's, you gotta know your powers. That's 5 cubed equals 125. 3. 5 to the third power equals 125. Same thing happens here. Log base 2 of 1/8. Well, you gotta think, how do I get 2 to 8? You cube it again, but it's flipped. Do you know how to flip it? It's a negative 3. A negative flips it. My answer here is this negative 3. Let's go to a tough one that people have a hard time with. Log, let's do 25, 5. You're like, wait, 25 to what power equals 5? How do I go from 25 to 5? Well, you square root it. And the square root power is 1/2. So the answer to this thing right here would be 1/2. That's how you do basic logs. You just go that bottom number to what power equals that top number. That's all it is. This number to what power equals this number. That's all it's going to be. You also got to know how to solve logs. But the trick to solving log is always the same thing. If you have a log problem, you take the base to both sides. You're going to go 3 to this side, 3 to this side. These cancel out. There's a rule. 20 equals 3 to the x. The way we solve this, only way to solve this is you take the log of both sides. Anytime you have a variable up here, you have to take the natural log of both sides, or log. What that does is it lets you bring this power to the front, my favorite rule about logs. And then we just divide by natural log 3. So x is an equal natural log 20 over natural log 3, which again, you can't do anything. Even if that was like 24, you can't reduce it like that. You just put that in your calculator or leave it like that. Let's do this one. These are both log problems. There's a slight difference. This one's way easier, but you do them the exact same way. Oh, it's a log problem. You get the base to both sides. These would cancel. That's just the rule. Log cancels 2, by the way. X equals 4 squared, also known as 16. Over here, same thing. There's a log on both sides. That makes it even easier. Take the base of both sides. You get x equals 5. Right? That's how you solve that problem. Keep in mind, if there's no base, it's base 10. If I give you this, that's base 10. You don't understand. That's called the common log, sorry. That's a 10. You take 10 on both sides. X equals 10 to the third. Natural log, if you say out ln x, that's a base of e. The way you get rid of it is the exact same idea. You take the e to both sides because that's the base of natural log. These cancel and you get x equals e to the fourth. That's how you solve logs. You want to solve a log problem, you take the base of both sides. If they don't show you a base, it's base 10. If you see a natural log, it's base e. You take the e to both sides. The way we solve this is to go, okay, let me rewrite this first. Right, it's a scientific notation, being punks. So you get 0.04. That's how you move that over. Move it 2 spots, 1, 2. The way we solve this, I'll do the very one on top. Only way to solve it is you take the natural log of both sides. So let's move this to the front. Natural log of 5 equals natural log of 0.04. Divide by natural log of 5. These are gone, and you get 2x minus 3 equals natural log of 0.04 over natural log of 5. All I'm going to do next is add 3 to this monstrosity, and you get 2x equals this stuff. And then we're just going to divide it by 2. Again, if you have a calculator, just put that on. That'll be some decimal right now. You just divide all that by 2. If you don't, you just get that as an answer. That's the way it works. Okay, let's go over some common log rules. Log A plus log B. If you're adding 2 logs, you're multiplying them. If you're subtracting 2 logs, you're dividing them. And then this one, my favorite, if you have an exponent, you can move it to the front. Or vice versa. If it's in the front, you can move it as an exponent. Again, this comes up a lot. You're going to see stuff like, they'll say, I don't know, 5 minus log W. And then we're like, put it all together. You go, okay, well, these two are being multiplied. You get log 5A. And the minus means it's being divided. You just divide that by W. Again, one solid log. If I put a 3 right here, well, the first thing you do is move that 3 to the top. It becomes a cubed. Again, it's going to happen a lot. Plus is multiply, minus is divide. Other log rules, we've been using this a lot. That's just basically saying if you have a base with the log to the thing, these cancel out, and you just get A. That's what happens here. Log without a base is base 10. These cancel out, and you just get A. E natural log cancel out. This is a more generic form of that. And another thing to know, if these match, they cancel out, you just get 1. That's actually a trick we're going to use. Now you see like 3 there. And we'll go, oh, I wanted to add it to this log 2, 5. What I'm going to do is I'm going to put log 2, 2 there, because that's 1. And then I can move this over there. I could do this. 2 to the third is 8. And then you go, okay, plus is multiply. Stuff like that. Other good rules you should know. Natural log of 1 is 0. Log of 1, likewise, is 0. Anytime you have log or natural log of 1, it's automatically 0. Anytime these match, they cancel out to 1. You can't take log of a natural number or natural log of a natural number. It doesn't work. And there's no such thing as log of 0 either. But that's how you do that stuff. Again, how to solve logs? There's 2 ways to solve it. We know the basic one we did earlier. The basic log problem is like log 3 x minus 5 equals 2. And the way we solve this is, oh, there's a 3 right here. Take that on both sides. These cancel. You get x minus 5 equals 3 squared, which is 9. Add 5, 14. That's how you solve a basic log question. A more complicated log question is like this. First thing, and I notice there's no base, so it's base 10. A lot of people just take 10 on both sides. You can't. You have to condense. You can only take the log on one side when there's a log on each side. So you have to make this a single log first. Remember, plus means multiply. First thing I do is go log x times x plus 1 equals log 2. I got to condense it first. Now I can do it. There's only a single log on each side. I can actually take the base of both sides. In this case, you don't see a base. It's base 10. Take 10 on both sides. These will cancel. And you get x times x plus 1 equals 2. Now we just use our algebra skills. You distribute x squared plus x equals 2. Anytime it's quadratic, the way you solve it is you set equal to 0 and factor. Or you complete the square. Either way though, set equal to 0. X squared plus x minus 2 is also complete the square, but no one likes that. X minus 1 equals 0. And you get x equals 1 and negative 2. Now here's the thing. I mentioned earlier, log has to be positive. Same thing with natural log. Can't have a negative. This negative 2 right here doesn't work. If I plug it in, I'm going to get a bad number. Actually, it's only x equals 1. And likewise here, there's a problem here. We've got to solve it. How do I solve this minus 2 there? What do I do with that? We're going to use this trick here of you can make this match the rest. We could write like this. Because that equals 1 equals log 3, 4. Something like that. And then what we do here is condense it again. I can't take the 3 of each side because there's multiple logs. I got to condense the side first. And the way we condense it is we move this over here. I get log 3x minus log 3 to the 9, 3 squared, which is 9, equals log 3 to the 4th. Minus means divide. Log 3x over 9, that's the way that works. log 3, 4. The way we cancel out a log is you look at the base and take that to both sides. These cancel and these cancel. X over 9 equals 4 times by 9, x equals 36. Okay, last thing with logs, change the base rule. So here, there's a rule, back in the old days you had to calculate and you had stuff like this. The way you do this on your calculator is you can split it. It's called change the base. You do log of the top one over log of the bottom one. The base stays in the basement. Now, there's another trick you can use also. We always did it with base 10. You can actually do it with anything. You can make it log base 4 to the 5th and log base 4 to the 3. It could be any base. So you could make it log base 2 to the 5th, log base 2 to the 4th. So that's just a slight rule with log change the base rules. You can do that. But how does that work here? Let me show you. So this is the thing IB loves to do. They'll tell you, hey, log base a of 2 is x, log base a of 5 is y, and they want you to write these following in terms of x and y only. Look at the first one. 20. You're like, wait, how can I use 2 and 5 to get 20? Well, 20 is 4 times 5, and 4 is just 2 squared. You do this. You go log a 2 squared times 5. That's the exact same thing as 20. Then we split it. Multiply means plus. It's an a, sorry. Here's the mistake most people make. They'll plug in the x right now. They're like, oh, this is x squared plus 5. Doesn't work that way. We got to move that 2 out of the way first. That power there. Move that out of the way. Now we're going to have this. 2 log a 2 plus log a 5. And you could go and go, hey, log a 2 is x. This is x, 2x, and this is y, 2x plus y. Again, very different than x squared plus y. You can't do it here. You're going to move the power to the front first. 2x plus y. This next one, log base 5 of 2. How do I do this? I have a bases. How do I get the base 5? That's this trick here. When you do change of base, you can make it any base you want. So we're going to do that here. We're going to make it log base a of 2 and log base a of 5. Because you can split it, top on top, bottom on bottom. You can make it any base you want. A log base a of 2, that's x. Log base a of 5, that's y. And there you go. A little tricky, but once you get it, it's actually not that bad. That's it for logs. Let's move on to binomial expansion, my favorite. Binomial expansion. This is that thing where it says into the effect of 2x minus 1, so 6 power, find term with x cubed. The way I taught you guys how to do it, to go, okay, here's the power. You always start like this, power on top. First term, second term, and then it's all about what power you want. I want x3, that makes this a 3, that's my extra third power. These two powers add up to be 6, 3 plus what equals 6, that's also 3, and whatever this is matches the bottom. And then from there you simplify it. 2x to the third, that 3 goes to both of them. 2 to the third is 8, x to the third is x to the third. Here, negative 1 to the third power is still negative 1. And keep in mind, they're being multiplied. My biggest pet peeve is when people just like add or subtract this. You're multiplying. This right here, there's a lot of ways to solve this. On your calculator is probably the easiest. If you have a calculator, turn it on. We're going to go 6 is on top. So this is the same thing. I should say this first. This is the same thing as 6C3. It's combination. On your calculator, you can put 6 math, go over probability, NCR, and then you put the other one 3. Hit that and you get 20. That's one way to do it. Here's the thing though. You might not get to use your calculator. They added this to the formula sheet. So if you look at a formula sheet right here, right there. So let me talk about how to do this. It's a little bit of a trick. N over R equals, this is the formula right here. N over R, I don't know why I put the block there, is N factorial over N minus R factorial, R factorial. How does that work? We have 6 factorial on top. N minus R is this 6 minus 3 is 3 factorial. And then R factorial, which is the bottom, that's your R, 3 factorial. So I just plug into the formula, 6 on top, subtract these, that goes there. How do you simplify this? Well, it's always a trick. You get the top number and break it down. That's 6 times 5 times 4 times 3 factorial. 6 factorial is the 6 times all the numbers below it. You have a 3 factorial, we're going to leave that alone. And then this 3 factorial is this 3 times 2 times 1. These cancel. You can reduce this. 3 times 2 is 6. That cancels to 6. 5 times 4 is 20. That's another way to do it, using the formula. And the last way to do it is using Pascal's triangle right here. The way to do Pascal's triangle, we do 1, then we bring down the 1s, 1, 1, bring down the 1s, 1, 1, add them up, 2, bring down the 1s, add the middle 2 up, 1 plus 2 is 3, 2 plus 1 is 3, bring down the 1s, 1 plus 3 is 4. If I was doing this, I need to get to row 6. I gotta go again, 1, 1, add these up, 5, 10, 10, 5. I gotta go all the way to 6, 1, 1, add these up, 6, 15, 20, sounds familiar, 15, 6. I say I have that. How do I figure out what 6, 3 is using Pascal's triangle? The trick is, this is row 6, because hence the 6. This is 6, 0, 6, 1, 6, 2. The trick is start counting at 0. 6, 3, 6, 4, 6, 5, 6, 6. 20. Either way, I get 20. 3 different ways to find it. Yes, calculator is the easiest way, but since they give it to you in the formula sheet, it won't necessarily be on the calculator. They could very well do it on the free response, on the by hand one. If you don't know how to do your calculator, you can still use the formula. Not that bad. I'll go over a couple more like that. Or you could write Pascal's triangle and then find the term they want. Again, the trick to Pascal's triangle is start counting at 0. If I ask you, hey, what is 4, 1? 4, 1 be, here's row 4. This is 4, 0, 4, 1. Anyway, to finish this off, you just multiply everything, and you get 160, negative 160 x cubed. So that's binomial expansion. Let's do some harder examples of that. Let's do this example right here. This first one, it's going to take forever. They want me to actually expand this all the way out. I have seen this on tests before. All we're going to do is they actually want me to do every single one. I'm going to start off with 4, 0, first term, second term. Keep on going until they match. I got to go 4, 1, 4, 2. I know I'm already bored myself. I just got to do it. 4, 3, 4, 3. And then 4, 4. All those. Then we do the powers. The power, the way it works is the bottom one matches the second one. These always match. And then finally to the last power, the rule is these two have to add up to be 4. That's 0 plus 4. 1 plus 3. 2 plus 2. 3 plus 1. I'm trying to add up to that number right there. 4 plus 0. And then from here on out, you just simplify. Where are you going? It's just mathematics. 4 to the 0. By the way, we can use Pascal's triangle right here. Since I already have it written out, I'm just going to use that. 4 to the 0 is just 1. 2 to the 9th, I have no idea. 2 to the 9th, leave that there for x to the 0 is 1. And then you do this one, 4, 1, look right there, 4, 0, 4, 1 is just 4. In general, guys, anytime it's over 0, it's automatically 1. Anytime it's over 1, it's automatically the top number. 2 to the 3rd is 8. That's a 4. Okay, 2 to the 4th is 16. Sorry, my writing's bad. Negative x to the first is negative x. Again, we multiplied. 4, 2, 4, 0, 4, 0, 4, 1, 4, 2 is right here. 6. 2 squared is 4. Negative x squared gets rid of, even power gets rid of the negative, so this is x squared. Plus 4, 3. 4, 2, 4, 3. 4 times 2. Negative x cubed, odd power keeps the sign, but still negative x cubed. And another trick, anytime they're the same number, it's automatically 1. Anything to the 0 power is 1 also. And negative 1 to the negative x to the 4th is a positive x to the 4th. So it's just going to be x to the 4th. Anyway, simplify this, you get 16 plus 30, negative 32. Sorry, so the negative there. Plus 24x squared minus the negative right there, 8x cubed plus x to the 4th. And that's expanding it the whole way. Look at this classic IB problem right here. Now you have that answer, they're saying, hey, find x squared when you multiply this by this. Keep in mind, we already figured out the second part, 2 minus 4x. So this is a harder example of binomial expansion. Every single IB test has a binomial expansion problem. Every single one. Most of the time it's something like this, find a certain term, but sometimes I'm trying to make it a little fancier and do something like this and like this. So let's do this. Keep in mind, this we just found right there. So this is actually just a problem. 3x minus 1 times 16 minus 32x plus 24x squared minus 8x cubed plus x to the 4th. Now here's a shortcut. You can multiply all that and figure out x squared. It's take forever though. Let's do this instead. What happens when you distribute? You multiply negative 1 by all those. What's the only one I care about though? X squared. The only thing I'm going to care about is negative 1 times this, because that's going to give me negative 24x squared. That's all I care about. Negative 1 times this is 16. Who cares? Negative 1 times 32, that's just an x. I don't care about it. Only one I'm going to care about this one is negative 1 times 24x squared. Yet though, I got to multiply 3x by all of these. 3x times negative 32. When I multiply those two, I'm going to get an x squared. I'm going to get negative 96x squared minus 24x squared. That's all I care about, because if I multiply 3x by anything else, I'm going to get x cubed, x to the 4th. It's just these two. Add them up. 0, 1, negative 120x squared. That's the answer. So that's a more complicated version of binomial coefficient stuff. But another version of this. Let's find the constant term. First, let's talk about what a constant term is. That is x to the 0. Constant term has no variable. X cubed, that's the quadratic term. 3x to the first is a linear term. And then plus 5. Constant term, but you can write x to the 0. So that's what we're looking for, x to the 0. But look at this. I have no idea where x to the 0 is at. So how do we do that? Like, I can't set up like I did before. I mean, you could kind of. You could like do 6, 2x squared, negative 1 over x. And then you gotta figure out the combination of powers here that gets you x to the 0. Sometimes it's not that bad. This one's actually not the worst, but most of the time it's gonna be a little confusing. What I do is I just try to find a pattern. I just list out the first couple. I'm like, hey, let's see what 6, 0 gives us. What does the first term give us? Something to this effect. Don't forget your powers. The way we do the powers is the bottom one always matches the second. And these two have to add up to be that one, 6. If I expand this one out, I get 1. I get 2 to the 6, x to the 12th, power times power you multiply. And then this is just 1. So I get x to the 12th. I gotta get to x to 0, so that's not gonna be it. 6, 1, see what the next one does. do the exact same thing. I'm just trying to find a pattern here. That's all I'm going for. That's 1. That has to match this one. 1 plus what equals 6? That's 5. So again, let's expand this out. I don't really care about that. 6. This is to give me x10. And this, I get, so first power is this. I'm going to get negative x to the 9th because it reduces. Look what happened. You went down by 3. So if I did 6, 2, I'll get x to the 6th. If I did 6, 3, I'll get x to the 3rd. 6, 4, I'll get x to the 0 power, which is what I want. The only one I really want to expand is 6 to the 4th. That's the only one I need to expand. Let's expand that one, because all I want is the constant term. So we're going to go 6, 4. First term is 2x squared. Second term is negative 1 over x. Let's not forget our powers, which are the bottom one always matches the second, and then that has to go here. So 6, 4. Let's pretend we don't have a calculator. The way I would do 6, 4, I would use the formula sheet, again, which says this. This is n, this is r. It says n factorial over n minus r factorial, r factorial. Don't freak out. What does that mean? It means we put 6 on top. N minus r is 6 minus 4 is 2 factorial. Then r is the bottom one, 4 factorial. How do I simplify this? You always expand the bigger number. Let's make that 6 times 5 times 4 factorial. Again, I can keep on going all the way down. Factorial is 6 times 5 times 4 times 3 times 2 is 1. But you stop at 4. Why? Because it's going to cancel with this 4 right here. You can't do anything about this one. We got to expand it out. So 2 times 1. These cancel, and you get 30 over 2, which is 15. That's how you do this without a calculator. That's one way. You can also do Pascal's triangle. What was this? 6, 4. If I go to my Pascal's triangle up here, 6, 4 would have been 6, 0, 6, 1, 6, 2, 6, 3, 6, 4. 15. Lots of ways to do it. Make sure you know how to do it without a calculator and with a calculator. So that's 15. Right here, distribute to both of them. 2 squared x to the 4th. A lot of people only do the variable. Number gets to 2. 4x to the 4th. Then here, negative 1 over x to the 4th power. All that does is makes it a positive because it's an even power. 1 over x to the 4th. And simplify this a little bit. These cancel. And all you get is 15 times 4, which is 30 times 2, 60. And that's it. We are done with algebra.